the last section we're going to be discussing is synthetic division. So synthetic division is a shortcut to the box or the long division method. I prefer synthetic only when the x does not have a coefficient in front of it or our divisor. And so let's look at how synthetic works. So you are going to write the root here. So when we were looking at that original one that we've been working with, and we've been having the x minus 2, that's going to be the 2. It's going to be opposite of whatever it is. And then you'll just write the coefficients up here. And then it's going to make more sense if I take and show you. But you drop the first, you multiply, then you add, multiply, add. And the last thing you have is going to be your remainder. And so you have to make sure there's not anything missing. And so I'm going down with all my powers. You're going to do the opposite of this. And so it's going to be negative 8. So go in this corner. And now I'm going to write all my coefficients. 1, 12, 41, 72. Now draw my line. You drop the first, then you multiply these two, and that gives you negative 8. Then you add, and that gives you 4. Multiply, and that gives you negative 32. Add gives you 9. Multiply gives you a negative 72. And so when I add, I get 0. This spot is your remainder. And so if this was originally your x cubed, down here it's going to be your x squared. And so that means this is x squared, this is x, and that's my constant. And so it's asking us to rewrite it as a product of our factors. So x plus 8 times x squared plus 4x plus 9 is equal to x cubed plus 12x squared plus 41x plus 72. As this algorithm works because of the fact that we're going to be working with just a coefficient of x. So that means we're only need to really worry about that 8, that last thing. So let's take this synthetic division that's outlined. This 2 is what is going to be coming up with the factor of x minus 2. Oh, that didn't write out very well. And so when we are trying to write the dividend, which is the first question asked, this is the dividend. And so we have 6, negative 3, and that has to have the x. And so we're going to step up. So this was x squared, x cubed, so that makes this x to the 4th. And so negative 4x squared, 0x cubed, and x to the 4th is my dividend. My divisor is what I am dividing by. So like I was saying earlier, we're going to do the opposite of that, so it's going to be x minus 2. My quotient is a solution. And so I step down by 1, and so it's become x cubed plus 2x squared plus 0x minus 3. And there is no remainder. And so now the last step it asks us to do is write it as a product. And so I don't really need to write these zeros when I'm writing it. So x minus 2 times x cubed plus 2x minus 3 is equal to x to the fourth minus 4x squared minus 3x plus 6. So now I want you to try to complete the synthetic division for this problem. So we are going to drop the 2, multiply gives me negative 6, add those, that gives me negative 10, multiply gives me 30, add gives me 34, multiply gives me negative 102, add gives me a negative 105, multiply gives me a 315, add gives me a 321. So it wants me to rewrite this as 2x to the fourth minus 4x cubed plus 4x squared minus 3x plus 6 is equal to the product of the divisor, or excuse me, of the divisor, of the dividend and quotient. Excuse me, yeah, divisor and quotient. My mind's just, sorry. And so we have to drop it down by 1, so that gives us 2x cubed this time, minus 10x squared plus 34x minus 105 plus, and it says write our divisor, the quotient plus the remainder. And so let's go ahead and write it in fraction form because we're writing it in this way. And that'd be over x plus 3. So so far we've only dealt with it when it's in this format already. But since they're not always in that form, you can still use synthetic division if you like it better than the box. But we need to factor it out. Because we have to have it to where the x is 1. And so that means that I'm going to divide both pieces by 2. So 2x divided by 2 gives me x. 3 divided by 2 gives me a negative 3 halves. Now, we just need to remember this 2 is here because that's going to come into effect our final solution. So I'm going to go ahead and draw out my synthetic division. I'm going to put a box here. And then go ahead and write down all my numbers as I go. 2, negative 6, 4, and 2. And draw my line. So I'm going to drop the 2, multiply, so 3 halves times 2 is going to give me 3. Add to go down, that gives me negative 3. Multiply to come up, and that gives me negative 9 halves. So when I add those, this is 8 halves plus a negative 9 halves gives me a negative a half. So if I multiply to come over, that gives me a negative 3/4. So this is the same thing as 8/4. And so that would give me 5/4 as my remainder. So that gives me 2x squared minus 3x minus 1/2 with the remainder of 5/4. So when I'm trying to work this out, and I want to go ahead and write out what the quotient is, so that's the same thing as 2x cubed minus 6x squared plus 4x plus 2. And that's equal to x minus 3 halves times 2x squared minus 3x minus 1/2 plus 5/4. So if I want this to be in the best form, it would be without this fraction here. So that means I need to factor that 2 back out, divide this one by 2, and then multiply by 2. So that becomes 2x minus 3. Now, if I was to divide that by 2, I have x squared. Divide that by 2, negative 3 halves x. Divide that by 2 gives me negative 1/4 plus that 5/4. And so if we want to verify something using synthetic division, that means I need to figure out, okay, what needs to come out of here so I can have it in the form of x minus r. So that would be a 3. That would be x minus 2/3. And so that would end up multiplying into here. And that gives you 3x cubed plus x squared plus x minus 2. And it wants us to use synthetic division to prove it. So what I'm going to do is I am going to look and see if I'm dividing by a 2/3, because remember it goes opposite. And so I'm going to divide 3, this information here. So it's going to go here. Plus 1 plus 1 minus 2. So I'm going to drop the first 3, multiply, and that gives me 2. Add gives me 3. Multiply gives me 2. Add gives me 3. Multiply gives me 2. And so that box for my remainder is 0. And so that became 3x squared plus 3x plus 3. These two match. So it checks out. So we're going to determine the zeros of each function. We're going to use information from the graph to help us. So one of the things the graph helps us is find one of the real zeros. And so it found out that it was -6 is one of my real zeros. And so I'm going to put -6 in my box. And then I'm going to put 1, 11, 37, 42. Drop, multiply, add, multiply, add, multiply. And since we know this is going to work out, we know it's one of the roots, this should be 0. And so that tells me x squared plus 5x plus 7 is my next step. So here's 1, 0. To find the other one, we already know it's going to be imaginary, so there's no point in us trying to factor. So let's go ahead and identify our A is 1, B is 5, and C is 7. So find our discriminant, B squared minus 4AC, so 5 squared minus 4 times 1 times 7, so 25 minus 28 gives me a negative 3. Now I'm going to evaluate that inside my quadratic formula. X is equal to negative b plus or minus the square root of my discriminant, all divided by 2a. So negative b is a negative 5 plus or minus the square root of a negative 3 divided by 2 times a, so 2. Well, we can simplify this down a little bit more. And so that would give us negative 5 halves plus or minus the square root of 3 divided by 2, and that negative came out as an I. So here's the other 2. So our roots are going to be here for all the zeros. Let's do this next one. So let's find out a spot that it does cross the x-axis at a good location. So that's going to be at 4. And so I'm going to use synthetic division to help me with this. Place the 4 here. Write down my coefficients, and this will be a little bit more challenging because we do have some decimals. But just remember, they get treated just the same as everything else. And so we're going to drop the first. Multiply gives me 4. Add gives me negative 75 hundredths. So 4 times 75 hundredths. 2 of it's going to be $1.50. And then 2 more is going to be, and then doubling that, it's going to get us there. So it's going to give us 4. It's going to be negative 3. So when we subtract, we get 0.125. And then we multiply, and we get negative, so we get positive a half. So it's a 0. So I know that I have x minus 4 times x squared minus 5 hundredths x plus 125 hundredths. And so I could try to factor this, and you could factor it. Or I can go on to the quadratic formula. It's really up to you which route you would like to go. Because of the complexity of this, I think a lot of y'all are going to want to go with the quadratic formula. So let's go ahead and go that route. A is equal to 1, B is equal to negative 75 hundredths, and C is equal to a positive 125 thousandths. And so my discriminant is b squared minus 4ac. So negative 75 hundredths squared minus 4 times 1 times a 125 thousandths. And so 75 hundredths squared is going to be 5625 minus 4 times 0.125 is going to give me a half. And so when I add those, I come up with 0.625. So my next step is to plug it into the quadratic formula. X equals negative b plus or minus the square root of my discriminant divided by 2a. So negative b is opposite of b, so 75 hundredths plus or minus the square root of 625 10,000ths divided by 2 times 1. And so when we take the square root of 0.0625, we get 25 hundredths. And so we have 0.75 plus or minus 25 hundredths divided by 2. And so when we do that math, you have 75 hundredths plus 25 hundredths divided by 2. And you have 75 hundredths minus 25 hundredths divided by 2. And so that's going to be $1 divided by 2, which is 0.5. And that's 50 cents divided by 2, which is 0.25. So my zeros of this function, I'm just going to go ahead and write it over here, are at x equals 4 at 5/10 and also at 25 hundredths. And so let's look at the next thing, and this is going to be the talk. You are going to work through for homework.